Cool. So I'm going to try and have the chat open. Yeah. So as Chris says, if you've got questions or anything to say, I'll try and keep an eye on the chat. So yeah, so my talk is on user events. It's similar to one I gave last November 2019, to the Northwest LabVIEW user group. So it's nice to sort of travel down the virtual M6 and be with the Midlands LabVIEW user group. So I'm just going to dive straight in. So just, sort of to be upfront, I think user events sort of sit on this pyramid of a good understanding of events and also the concept of dynamic events. So I'm trying to start from like zero. I'm sure lots of you will already be well versed in events, but hopefully there's things you might be able to take away, or you might be able to chip in any thoughts or ideas you have. So yeah, so the most of this talk is sort of just looking at events in general. And then we'll take a quick look at user events and yeah, and sort of, so I'm a work as an academic researcher. When I have a question, I go to the most well-respected academic resource, which is Wikipedia. So yeah, so their definition of an event is an action or an occurrence recognized by software. It often originates asynchronously, and we're going to handle it in our software. So I think that captures how events work in LabVIEW pretty well. So yeah, I guess the big question is why do I like using events? There's a number of different things. Firstly, I really like sort of asynchronous sort of architectures. I don't know whether it's just because I'm impatient and I don't like waiting for things to sort of so I don't like sort of blocking the loop of your main functionality, or whether it's just sort of how my brain works. I'm not quite sure, but yeah, I really like sort of asynchronous designs, and events work really well in that context. You're able to control if and when you care about specific events, which means you can use them for some quite complicated managing user interactions, or yeah, different sort of messaging frameworks. And yeah, there we go. So yeah, great for messaging between your different application components. And by components there, I mean maybe sort of two parallel running loops, or perhaps two actors, or different sort of modules, that sort of thing. So I guess the first thing looking at events is what in LabVIEW can generate them. You've got a couple of different options. The sort of, I think one of the main ones that you first encounter, certainly maybe the start of core 2, maybe it's the end of core 1, is user interface elements. So that's your Boolean buttons, your text fields, basically anything on the front panel probably has some sort of event connected with it. Typically that might be like value change, or maybe stuff with the mouse, so like mouse over, mouse enter, mouse click. Other sources are what I'm referring to as the LabVIEW runtime. So while your application is running, there's a number of events, things like a panel close, like this sort of application shutting down. There's a couple of events that you can connect to and handle. User events, the sort of from the title of this talk, which I'll get onto quite a bit later, but that's an event source. And I have seen certainly some DAC-MX devices appear to throw events, but I've never actually had a physical piece of hardware that is compatible with that. I don't know if anyone has. It would be fun to play with, but I've never had compatible hardware that does it. So just quick check on the chat. Okay. Right, so those are our event sources. Then we've got these events happening. How do we decide what code we want to execute when that event occurs, which is the concept of handling the event. So how do we handle the event? I think I assume the only way, but the way that you do it is using this thing called the event structure. So it looks a bit like a normal case structure. It's got a sort of a jazzier border with this I guess it's a sort of beige and light grey border. You have this terminal in the top left, this little hourglass, that is so you can specify the duration of the timeout in milliseconds, and you also sometimes have nodes within each case that provide data associated with that event. And you can drop that from the events structure palette. It's also in the dialog and user interface palette. And I think the shortcut is EVNTSTR on, or maybe it's just EVSTR in QuickDrop for you QuickDrop fans. Yeah, so we've got our event sources and we've got our event handler. Question is that, there's a missing piece. And the answer to that is going to form a good bit of this talk, and that's looking at event queues. The event queues were a thing that was sort of a bit mysterious to me until I was able to really have a good sort of deep dive. I think this is one of the areas where I struggled most with the documentation around LabVIEW events, is that it sort of isn't quite clear. Well, it wasn't clear to me exactly what the documentation was going on about, and it's only really with playing with it and trying to sort of find a mental model that fits that I've really got to grips with it. So I think I'd be interested in if other people found a similar thing or sort of where they are on the journey. But I'll crack on with the talk. So there's two main categories of event queues in LabVIEW. There's the what I'm calling the VI's internal event queue. So that's where these things called static events live. You don't really get much access to it. It exists for the lifetime of the VI, and it's sort of all managed behind the scenes. And then the interesting one for me is this sort of dynamic event queues. So you can create, well, they're much more flexible, but you have to manage their lifetime, and there are a few sort of gotchas with how you might use different aspects of them. And of course, you don't have to use these dynamic events, but that if you want to use user events, it helps to have a good understanding of dynamic event queues. At least if you want to do, or at least it explains why sometimes the behavior you weren't expecting happens. So the static event queue, I'll just take a quick look at that. So I imagine most people will have, for instance, put an event structure that's listening to like a button press. So you have your event structure in your block diagram. You right click on the border, you go edit or add events, and then you bring up this dialog, and then you can see your different event sources, and you can choose the event that you want to handle. So I think that's all reasonably straightforward. And then in terms of being able to manage the static event queue, I think the only chance you really get to interact with it is this option when you're editing or adding events, is to limit the maximum instances, of this event in the event queue. So that means if you press a button sort of lots and lots of times whilst your code isn't actually handling the events, they just sort of get queued. You can actually say only put, I don't know, three of these events in the queue. I think that's very handy for certain numeric controls that, as you're, for instance, a numeric dial, as you're rotating it, you can get lots and lots and lots of events generated, and you might not want to have to handle very small incremental changes in number. You probably just care about a small number of those, especially at the last value, and that's what this will do. It'll sort of keep the most recent events and discard the older ones. So that can be useful, but it's essentially the only control over the static event queue that you have. So now we go into the topic of so a quick warning here. You don't want to be handling the same static event in different event structures that's within the same block diagram. In a way, you have your event queue in the background, and it has let's say you press a button, it has that button press in the event queue. And if you had two event handlers looking at it, would one get it first? Would they both try and process it? It sort of leads to some, I think, undefined behavior. So yeah, best avoided. Yeah, there are alternative ways of handling a button press in two places, which is actually by dynamic events, which we're coming on to. But yeah, so just be careful with your static events. only handle them in one place. Right. So yeah, cool. Still nothing in the chat. So dynamic event queues. I think, yeah, this is the thing that I struggled with first when I first encountered them. I think it was looking at something like the queued message handler, because I think when you first encounter them, it's not clear how they're different from a normal queue, and this whole idea around registration. But I'm going to try and go through it and sort of explain what's going on. So if you want to create a dynamic event queue, you need to register an event source. So LabVIEW provides this register for events nodes. You connect your event sources on the left-hand side. As you'd expect, you can expand this node as you wish if you have multiple different event sources, and then you get out of this an event reg refnum. So that, for me, sort of symbolizes the event queue that you've created. You can use this node at any point in your application, any sort of time. It doesn't have to happen at the start, which is sort of how we're getting onto this idea of being able to sort of manage the lifetime of these queues. They don't have to be there at the beginning, and you can get rid of them before the end of your application execution time. So when we come to using these dynamic events, we can't just rely on right-clicking on the event structure straight away. We have to make sure that we have these dynamic event terminals shown. So these are the sort of greenish terminal in the middle of that case structure, left-hand side edge. And if we just go through what's happening in this diagram, I'll try and turn on my pointer. So yeah, hopefully everyone can see the laser pointer there. So what I've done is I've got a reference to a button, which I can use as an event source. I then register on that event, and I get my event registration refnum out. I wire that into my dynamic event terminal on my event structure. I then specify that I want to essentially do something with that event, and then once I'm done, I no longer need that event registration, so I can destroy it, and that makes sure that we're not having any, leaving any objects in memory that we're not using. So I think that's quite. I think that's quite straightforward. Certainly for lots of events, you sort of care about them for the entire duration of your application. So you just create them at the beginning and then destroy them at the end, and you sort of know that they're always there. And when you're adding those events, you get through to your, you do it through the same way that you do with, sorry, I'll just turn the laser pointer off. You do it in the same way that you would static events. So they just appear under a slightly different heading inside your edit events. Yeah, there we go. So one thing that I don't think I realized when I first used these was how that event queue is managed for you, or how that dynamic event queue is managed. So looking at this example, do I have I can't point and click. Right, so so we have the same setup we had before. We have our button with a reference to that button. We register on the value change event, and that gives us our event registration refnum. We then essentially simulate a button press, so we can do that using the value change property node, or the value set property node, but the one that has signaling, and that means that when we write to that, we'll also generate an event for it. Then we go into this, maybe I can do the laser pointer and click. So yeah, so then we go into our first event case. So this event case only has the timeout case added. It doesn't have any of the cases. The timeout is wired as 0. So what that means is it will immediately execute. It's not waiting on any other data. We have wired our event registration refnum straight through, so it reappears here unchanged. But what that has done is, because that first event structure has no value change button case created. It essentially just silently deletes it. So then when we come to try and handle that event, we'll see that the event that we did have queued has gone. So let's just bring that up. Yeah. So therefore, in this case, the application will wait until the button is pressed again. Then this second event case will execute, and we can then destroy the event registration ref num. So sorry, just check the chat. Okay. Yeah, so I think this is quite interesting for a number of reasons. It means that if we register on an event and then pass that into an event structure, essentially we're not going to get a memory leak. Whenever that event structure runs, it'll just delete anything from the queue that we're not handling at that time. And I think that makes life a lot easier later on. So that's always worth bearing in mind. Let's get to the next slide. And then I'll just leave the pointer. So yeah, so obviously you're probably not going to just wire up a load of event structures in sort of one after the other. You're going to put them in a loop, and that's then when you get this concept of an event handling loop. Yeah, so wrap your event structure in a loop. It runs until you hit a stop, and then you tidy up afterwards. And you'll probably have seen, well, that's essentially the event handling bit of like your queued message handler or your DQMH module. And yeah, so if you want to dynamically unregister, so for instance, you don't care at this point in your application if that button is pressed, you just simply modify within your event structure the registration. So you wire in and it's essentially an empty reference. And that will then mean that even though the user's pressing that button, the event isn't being listened to anymore. It's essentially being silently dropped. So that then gives you the idea of like listening to the events when you do and don't care about them. I think if it was a button, you might just use something like the disable property, so the user can't click it. But let's say you had some other module that's sending out like updates and you don't care about the updates, you can just essentially unregister from them and you don't have to worry about handling them. And then there is an alternative way of doing this, which is to simply just, if you don't need the event registration, you could just destroy it. And that's you unregistered from the event. I'll just quickly check the chat. Okay. So when we look at expanding that event registration node, we were able to put in multiple event sources. So here I've got a button and I've got registering on this VI, and that then produces still a single event reg ref num. And we then, if we want to modify it, we only need to wire the modifications into the nodes, into the terminal on that node that we care about. So if we leave it unwired, it means don't modify our current registration for that event. And that works the same as our previous diagram. And another function of the event or register on events node is that it will accept a cluster of different references. Yep, so there we go. We wire in a cluster here and we still get a single event reg out. We can also register arrays. So if we put in an array of references, we can then handle, that sort of almost aggregates multiple different event sources into a single event handling case. So yeah, here, all the buttons would be handled, all the button presses would be handled by the same case. And if you want to determine which button was pressed, you could use something like the control ref value that appears here, and then like read the button label or do something. So yeah, currently we've got support for single references, clusters of references, arrays of references, and also you can expand the nodes to have multiple single sources in. And then to further confuse things, the dynamic events terminal on our event structure will also accept a cluster event registrations. So this works very similar to all the other cases. You're just starting to get a slight changing in how these events appear to be structured. So you'll notice here now we have event registration refnum dot button, and I think that's different from the previous case. And then when you want to modify that event registration within your event structure, you've got a cluster of these refnums that you can modify. So it sort of depends. The different uses depends maybe on how you want to handle those dynamic events. Sometimes you're able to, I think the easiest thing is if you can put all your different event sources into a single refnum, but you won't always have that option depending on your architecture or how you're using different event sources. So yeah, you've got those different kinds of support for different sort of structures of those event registration refnums. Sorry. So then you can start getting really deep. You can have sort of bringing it all together. You can get really confusing structures. Or well, I mean, they might be confusing to you. They might not be, but you can get certainly quite complex structures. And here you really start seeing how the sort of granularity you can get in like the event naming. So we've got, in this case, this is the event refnum name that will appear first in the list. Then you've got the cluster name, which is from here, and then you've got the name of the button. So you sort of get all this thing, and you could then work out, oh, okay, so this event is from this event source. But yeah, it's not the like I say, it gets quite complex. The other thing to bear in mind is that if you were to change this name, unless you changed this event registration as well, you'd see the old name, because essentially how you're creating these constants here, they sort of take the value at the time of creation, so that the data type would match, but you wouldn't see the name update. So that can cause confusion sometimes. You'd have to just recreate this constant with the new name, and then you'd be able to see the updated name here. And on that naming front, you can also sometimes find, let's say if you've got, you're building an array of different event sources, in this case buttons. So this array would come out with a sort of not very nice name, but you can use the coerce to type functionality to then essentially apply this nice name to this reference, and then that registration events refnum will have a nice name in your case structure, in your event structure. And that coerce to type it's more visible in the later versions of LabVIEW. It's just in the conversion palette. If not, you have to go sort of digging for it. I think LabVIEW 2015, maybe it's harder to find, and earlier than that. Yeah, so that there's quite a lot of different things you can do with event registrations, and also the dynamic terminals on your event structure. Yeah, it like I say, it gets quite involved. So yeah, there are a couple of pitfalls that I mentioned earlier, and I think I'm just going to go over them now. So when you're modifying your event registration reference, it's best to wire it all the way through. So the default behavior actually is if you leave both of these terminals unwired. So I'll bring my pointer back. If you leave both this terminal and this terminal unwired, it's all like the registration is passed through unaltered. If you happen to change it on the outgoing terminal, then you have to wire through. If not, you'll get undefined behavior. I think sometimes it causes the UI to hang, but I can't exactly remember. Just make sure if you are modifying your event registration refnum, you wire the terminals all the way through. The next thing to watch out for is, sorry, apologies for the dog barking. I presume the postman's come and he's unhappy about it. So the next one to watch out for is branching your event registration ref num. This is very similar to having with your static events, essentially creating two event structures that listen to the same like button press. So here what we're doing is we're branching our event registration ref num, so we're creating two possible handlers for the same queue, and that will cause issues. I can't remember if sometimes one will handle the event and one won't, or whether sometimes the event just gets dropped. Certainly, it's undefined behavior. So yeah, don't do that. And then the other thing that I found when I was playing around with events, and I think my understanding of them wasn't quite sorted yet, and I thought, oh well, could I nest them? So but this is very similar to the branching. You've sort of created two event structures which are listening to the same queue, and it will. I think that one causes LabVIEW to crash. So yeah, don't do that one either. So just quickly check in on the chat. Yeah, okay. So I think we're finally now at the point where we're going to look at user events. So I think that's probably about 25 minutes in. Yeah, so like one of the things that I love about user events is this whole, you can dynamically register and generate events as you want. It's like, that makes it really good for this asynchronous communication. Because events take a data type, or they're typed like most things in LabVIEW, they're great for essentially keeping that strict typing all the way through your application. So this is a basic example of using them. So we create our user event using the create user event VI, or perhaps it's generate user, I can't remember. Well, it's got one of those names. But anyway, we create our user event with a data type. In fact, I think there's descriptions here. Yeah, so we create the event. I like using a type def because, I mean, type defs are generally always a good idea, but if you're especially if you're sort of creating queues or user events from controls, best to use a type def so they're easy to modify in the future. If not, you have to do lots of manual editing to get the types to all work out. So yeah, so we want to create the user event, and then we want to register before we start sending events. If we don't register before we start sending events, then we'll lose some events. So we do our registration. Then in our bottom loop, our simulate temperature data loop, we're just we're generating some random data and just putting it in the creating or firing that user event. And you have options with priority. You have normal and have high priority. I believe high priority just essentially would jump it to the front of the queue or jump it to the front of other normal priority events that you've queued. And then when we're getting that data out in our top event handler loop, we automatically get this cluster unbundled, which can be quite a nice feature. It can also be quite annoying if you're sending something like an error. It'll automatically unbundle it. So the easiest thing to do is just wrap your error in another cluster. But yeah, so you get that data out, and then you can do with it what you want. In this case, we're just displaying it on the UI. And then once your application stops, so in this case, I think I'm listening for the panel close event, and that's would then be how I shut down my application. I haven't got it shown here, but when the top loop detects that the panel is being closed, it will destroy the user event ref num, and that will then cause an error in this lower loop, and everything will stop, and then just tidy up your event registration ref num at the end. So that's a quite basic example, and I think if you've done stuff with the queued message handler, you'll have seen that sort of stuff happening. Yeah, so that's I think that's kind of not too bad to get to grips with.
John, you got a question?
Oh yes, hello. Is it best to type def the event or use a variant? Yeah, so sorry, that's a question from Craig. He's asked, is it better to type def the event data or use a variant or other? So I guess it depends on your preference for sort of following strict using the static typing in LabVIEW. If you were to wire a variant in, it makes it quite easy to adapt to changes with your architecture, but you then have to make sure by doing essentially make sure you're running tests to check that when you come to convert that variant data back to the data you think it should be, that you're handling that properly, or that you haven't accidentally modified the data that you're putting to a variant in one place and then not converting it properly at the other end. So my preference, I like using typedefs because I often make changes and then have to spend a while debugging to find areas where I've made a change and it's not come through automatically. So yeah, so hopefully, Craig, that makes sense. It's sort of down to you as the LabVIEW programmer, whether you prefer dynamic or static typing. But yeah, I mean, typedefs are always my preference. So I'll crack. Cool, thanks. So yeah, I'll go on to the next slide. Yeah, so in terms of asynchronous communication, we'd have some asynchronous process, so that could be a sort of like an actor or a DQMH module or some sort of, essentially it's a loop running that has that you otherwise couldn't sort of just access through normal data flow. So you'd maybe you could, if you wanted or the asynchronous communications, the flow that I like is that you would say to that process loop, hey, please send me some data, and I would enclose with that request message the user event I'd want them to send the reply on. So that's quite nice when you've got your asynchronous process that spits out data. So it could be temperature or some other sort of data logger that's running that you just want to get that data back from. Yeah, that's the sort of case where you'd say I'm going to subscribe to this data, yeah. So sorry, 1 second. Yeah, so I think that's the use case I'm describing. Is just you've got some loop running that generates data and you want to subscribe to it that way, and yeah, then you say, yeah. Sorry, I've got a bit muddled with this slide, but I think I illustrate this better with the next one. So I'm really trying to get on with the whole concept of user event lifetime. So let's say you want to send a message and get a reply. It's like a one-time reply to your particular request. One of the nice things about user events is the lifetime of the event source, as in our user event, and the lifetime of our event registration are decoupled, or sort of separately controlled. So going through this, we can create our user event, we can register on it, and then this would essentially be our external process, would send the reply and destroy that event, that user event message, that user event reference, but this case will still execute. So whereas let's say we were sending a notifier to get data back on, we would have to make sure that when we receive we wait on the notifier, we get the notification, and then we'd have to destroy the notifier. In this case, you can sort of create a channel and really essentially manage its lifetime very easily by just destroying it, and that the event will still come through because you've not destroyed that event registration. So I think that's sort of a more specific to different communication frameworks that you might try and develop. But this is one example where LabVIEW documentation suggests that when you destroy this user event, you also would destroy the queue, but it's not the case. So yeah, it's sort of when I first came across it, it wasn't very clear in the documentation, but I think playing with that really helped. So I sort of the reason why I got into lots of this user event stuff was because I was sort of looking at it for a strictly typed messaging framework. So I sort of, this is a shameless plug for my GDevCon #2 talk, which is on YouTube, and doing that was a lot of fun. So yeah, just sort of summing up, I think events provide really useful features. I especially like user events. you know, there is a bit of a learning curve with using them. I think lots of that is around the dynamic event registration. The fact that they're called user events, when you're like, but who is the user? Am I the user as the programmer? Is it for the person using the software that's the user? So that's, for me, that's one of the learning curves, is just understanding the nomenclature. And then yeah, if you sort of have a play around with them, you know, you learn where the pitfalls are and you learn to avoid them, and then yeah, you know, see what you can do. So yeah, that's the end of my main talk. If you've got any other questions, I'm happy to talk about them, or you know, whatever.
Thanks very much, John. Yeah, anyone got any questions? I've got one.
Yeah.
How have you oh, someone's chucked one in here actually. So Luis has got one. Is there a limit for the number of events to handle?
I guess in terms of a limit, so maybe yeah, there's sort of two ways of interpreting that question. I might just try and answer both. It might be useful either way. So I discussed with static events, you can limit the number of instances of that event in the queue. With dynamic events, you can also manipulate the event queue. There's a VI that lets you sort of flush and filter out events. So that helps you sort of essentially limit dynamic events within your event queue, within your dynamic event queue. The other thing is, if you're talking about like looking at a classical LabVIEW queue where you could create essentially a lossy queue, you don't have that option in the same way. So if you, for instance, had a queue, you were putting lots of data into it and you weren't handling that data at the same rate, you would see your memory usage sort of start, you know, increasing, because they're there, they exist, they're waiting to be handled, but they're not being processed. So yeah, there's a sort of physical limit, which is the memory that your system has available, and you don't have that what can be quite nice feature of a normal queue of having like a lossy enqueue option. So hopefully that answers that question. But I'm happy to contribute more if required. Oh, I see Steve has a question saying, do you ever use functional global variables to make event ref available throughout a project? I don't. I generally like wiring event references through. It can make your diagram a bit messier, but it's just my sort of personal preference. I like to know, I sort of like to control, I like to be quite peculiar about how I control where the reference is. And I find sometimes FGVs can allow you to sort of get access to a reference that you maybe shouldn't have at that level of the application. So it sort of depends, you know, how you want to manage the data. I think I'm wrapping like an event mechanism within a class or something. So I'm sort of I have the extra layer of control over what can read, what can write, what can do things to the queue. But yeah, FGV, certainly if you want a nice, neat diagram, or you're carefully managing like how your API is used, I think they're great for a range of different applications. So hopefully that's right with that. That's answered Steve's question.
Good stuff. I'll jump in with mine now then. Have you had any experience of with user events whereby you they get received not in the order that you send them? So I know that maybe queues user events aren't the best way of managing the order of stuff, but just wonder whether you had any experience of that.
I don't think I've seen anything like that happen. I guess sometimes when you're talking about mixing like static events and dynamic events, you sort of, it's down to like LabVIEW's internal mechanisms as to which event it thinks happened first. And then when you add in the fact that you have dynamic event priority as well, then that can start causing that can start shuffling things around in the queue. Yeah, it's a bit opaque. That is one of the downsides, is that you maybe don't have the same visibility that you would for a typical queue. But yeah, I don't think I've had any problems, but it might just be because I've not been pushing pushing it too much. Yeah,
because I think what our experience was that we kind of had it was a dynamic user event. We had two events, and we were sort of sending them with no time in between the sending, and we saw that sometimes the second one would be received first and before the first one. But yeah, that was relatively niche case,
yeah.
I guess.
And I guess that's an example of where you might want to sort of create like atomic actions. So much like with a normal sort of message handling loop, let's say you need to have, you know, operation A happen and operation B happen immediately afterwards. Best to sort of combine those in a single message that says do operation A and B instead of queuing the messages for A and B. You've still got, you know, whenever you have an enqueue, like stuff can happen in between those two options.
Nice. Yeah. Cool. Any other questions for anybody? Doesn't look like it. Well, thanks very much, John. That was really great. Really interesting presentation, and I enjoyed that.
Yeah, thank you very much for having me. It's great. I'm looking forward to the rest of the session.
Nice one.